Okay, so here is the summary what we have seen about the calculations. What remember that what we are doing, we are generating 1 hertz pulse square wave, 1 hertz frequency, 50% duty cycle, means half of that time will be on and half of that time will be off, and the crystal frequency that we have to the microcontroller is 20 megahertz, and based on that our T0 con is 0x05 and TMR0H will be 0x67 and TMR0L will be 0x69, right? The value that we had calculated was 6769. So 67 goes into higher register and 69 goes into lower register. Okay. Okay. So now we want to write an assembly language program for this. Some of you have sent me the programs with a little bit, maybe some mistakes, something was missing. So we will see today the full program so that you can check with yourself and then try to find out what mistakes you made or what you missed. Some of you missed something, almost whatever was written was maybe correct, but something was missing. So we will see now the program. Okay. So now we are first writing assembly language program for generating 1 hertz pulse on pin RB0. So first thing which many of you missed was, since we want to generate a pulse on RB0, right? RB0 is a pin, right? It is part of port B, RB0, right? It is a part of port B, pin 0 of port B. So since we want to generate a pulse, means there will be a transition on that pulse. So we want some signal to be sent to that pin, means we want to set that as a output pin. So that has to be done through the TSSM'S register. This one step was missing in some of your programs. Okay, and as we have seen many a number of times, that when we want to set a pin as output, what we do, we make that particular bit as 0, BCF. What is this instruction? Bit clear in F. F in this case is TSSM'S and bit is 0. So we are clearing bit 0 in TSSM'S, means bit 0 in TSSM'S corresponds to RB0, right? So when we set it to 0, when we clear it, then that particular pin will act as output pin, right? Remember, we are doing this on TSSM'S so that RB will become output. Okay. Then these two instructions work in a couple, right? What we want to load value 0x05 in T0 con. T0 con is what? Timer 0 control register, right? For the configuration of timer 0. Its value, what we want, as per our calculations, we have calculated that it has to be 0x05. So to load that value, see, we cannot load the value directly to T0 con. We do not have any instruction like that. We do not have any instruction of that format where we can load some value directly into a register. What we have to do, we have to first take that value to W through the move LW instruction. Means this is a literal. In this case, when we say move LW, this is a literal 0x05. That 05 goes to W, and then in the next instruction we will move the W to F. Means now this 5, when first it goes to W, and then from W it goes to F. Now F in this case is T0 con. This is how the value 05 goes to T0 con, right? This is This kind of pair we have been using a lot of times because this is the only way through which we can load some value directly, some value in a register. We have to use these two instructions for that. Okay. So this was one thing, one setting that we had to copy into T0con. What were the two other things? Two other things are one, this one and this one. So how can we do this? Somebody can reply me now. How can we do this? How can we load 67 into TMR0H? How will it go? How will the value 67 hexadecimal value go to TMR0H? What instructions can we write? Can someone tell me now? Am I audible? So is this so difficult question what I am asking? What I want this value to go to TMR0H. Here is a direct example before you that 05 value is going to T0con. Now I want 67 to go to TMR0H. So what should be the instructions?
Move LW0 X67 and
Yes.
move WF TMR0H.
Yes, that's what, right? We have that is the only option. Move LW, the value, and then move WF TMR0H. Right? These are the only two instructions that you can do. You can write. That is the only way that you can move some value to a particular register. Now the next thing what we want, 69, 0x69, we want to move this value to TMR0L. So what should be the instructions? Again the same things, right? Again the similar instructions. Move LW 0x69, move WF TMR0L. So 69 will go here, 67 will go here, right? With these two instructions. Here 05 has gone to T0con. Why? What is this? This is what? This is a label that we have given. If you can recall, this was the step 2 in the when we discussed about the steps to program the timer 0. And we want to go here again and again. That's why we have put a label here, because at the end we will write some kind of a jumping instruction or looping instruction. Okay. Now what should be the step? What should be the next step now? See, we have done this. We have done this. Now what? We should clear this flag and then start the timer. Okay. So to clear the flag, we have BCF instruction again. But for this BCF, what we need? BCF works in what? What is this BCF? It is going to clear a bit in F. That's why we must know where that particular bit is. TMR0IF is the flag, means it is a single bit. We want to make that bit as 0. But where that bit is located, that has to be known. Means in which register it is. So we must remember that this TMR0IF is in INTCon register. Okay, that's why this instruction we have to use, that BCF means bit clear in F, that F is INTCon and the bit is TMR0IF. So this instruction, what will it do? It will clear the bit TMR0IF in the INTCon register. Okay. Now what should be the next step? What should be the next step now?
Start the timer.
We should now toggle the bit, because this is one thing that we want to do. Actually, this is what we want. 1 hertz pulse on RB0. How will it pulse? Means on, off, that should happen. So we have to perform that operation also. This is that particular operation, bit toggle, BTG. If you recall this instruction, what is this? Bit toggle, that's it. Toggle this particular bit. Which bit? Bit 0 in port B, means RB0 bit, right? Bit 0 in port B register. So this instruction will just toggle. If it was 0, it will make it 1. If it was 1, it will make it 0. That's it. And now there will be a delay. Once it shifts the value from 0 to 1 or 1 to 0, there will be a delay. So here actually we will start our timer, because now we want the actual delay. So how to start the timer? By making TMR0 bit as 1. So TMR0 on bit, where is it? It is in T0 con. How to make it 1? Bit set in F. This is the instruction. Set bit in a file register. So which bit? TMR0 on bit. And which register? T0 con register, right? So what we want now is, we just want to start the timing. We want to start measuring the time pulses. So by setting this particular bit 1, the timer will start measuring the pulses. Now how many pulses it is going to measure? What, if you can recall, I have shown you something like this. These are the values of TMR0 HL pair. Okay. So it starts from 0 and goes to FFFF. Right? But instead of starting from 0, we are starting from 6769. Right? Because in TMR0 LH or TMR0 HL pair, we have loaded 6769 value. So when we start this timer at this particular instruction, when we are starting the timer, it is measuring pulses from here. So it is just going to increment from here. And once it becomes FFFF and another pulse comes in, it will overflow to 0000. And when this overflow is happening, what we are going to do, or what will happen when overflow happens? This TMR0IF flag becomes 1. This particular flag, which we have made 0 in the beginning, that flag will become 1 when this overflow happens. So we can know, we can keep checking this flag, TMR0IF flag. If we can keep on checking this flag, if that flag becomes 1, it indicates that these many pulses have appeared. If TMR0IF flag becomes 1, we know that these many pulses now have finished counting. So we will just keep on checking that flag, and that we can do using the instruction BTFSS. What is this instruction? Bit test in F. So what is that bit? Bit is TMR0IF. And what is F? INT con. Means we are again checking the same bit, right? We had cleared this bit here. We have made it 0. And now we are checking whether it is 1. What is this instruction? Bit test F. We are testing this bit. We are checking this bit. And what we are going to do? What is meant by SS? Skip the next instruction if the bit is set. Skip if set. Means what? If this bit is 1, we will not execute the If that bit is 1, we will skip the next instruction, means we will not execute the next instruction, and we'll jump ahead. So what should be the next instruction? It should just go back here. That is what the instruction should be. So what is happening? Can you guess now? If this bit is 0, this is not going to skip. So this instruction will be executed. If the bit is 0, if this TMR0IF bit is 0, it will just execute this instruction. And what is this instruction? It is just going back to the same instruction again and again. It is going to the label again, which is here again, right? So what we are doing, as long as that bit is 0, we'll just keep waiting at this particular location without doing anything. And when this bit becomes 1, when this bit becomes 1, what will happen? What it says, skip the next instruction. So next instruction is this. So we will directly jump here and we will execute the next instruction, which should be now clearing the timer 0 on flag, means stopping the timer, right? Because you see what has happened when we cleared this flag and then we toggled the bit, toggled the port, our port RB0 bit, and we started the timer. So when we started the timer, it started measuring from this up to this particular point, and when this overflow happened, means when this measurement completed, the TMR0IF flag became 1. So these many pulses have been completed. Yesterday we have seen that these many pulses means how many pulses? Those were 39063, something like that, right? Something like that. So these many pulses have been measured, means this corresponds to 500 microsecond. 500 milliseconds. This corresponds to 500 milliseconds. So the delay required has been now completed. That's what we can guess from the flag becoming 1. This TMR0IF flag becoming 1. Okay. That's why we are now stopping the timer. We will stop the timer here and then just jump to here. What is this? We stopped the timer because TMR0 value had become 00 on overflow. So we will stop it and we'll jump here, right? See, what is this instruction? Loading 6769 into TMR0 HL pair. This particular loop branching to here. What is that? It is going from TMR0 HL equal to 0 to TMR0 HL equal to 6769. That's how we got here. And then again we are starting. We are clearing the TMR0IF flag. Then we are toggling the bit. So let's say at the beginning the bit was 0. So when we toggled here it was 1. And now the next time when it comes, it has become again 0. Again the same amount of delay will be inserted in between. And again we will go back here and this loop will continue infinitely. The loop will continue infinitely, right? So this is how we have we can generate 1 Hertz pulse on pin RB0. If you can see, these instructions are exact replica or exact translation of the steps that we have written on some previous slides. I will again show you that slide. Okay. See, these are the same steps. Load T0 con that we have done by loading the value 05. Load initial count, we have done this by making the initial count as 6769. These two are based on calculations that we have performed. Clear TMR0 IF flag. So for that we have used instruction BCF. Run the timer. For this we have used instruction BSF, because what clear means we want to make this flag as 0. That's a BCF. Here we want to start means set TMR0 as TMR0 on as 1. So we have used BSF, bit set F, right? Keep checking the flag. For this we have used BTFSS. And when it what we said, keep checking. So we will keep doing the same thing again and again. That's what we had done, right? If it is not 0, we just waited. If it is not 1, we kept running here only. When it became 1, we moved ahead. And for this, when we move ahead, what was the instruction? We want to stop the timer. TMR0 on equal to 0. So again BCF, clear the bit. Okay, and then go to step 2. Here again we have used the branching instruction, and from here we went to this, right? The label given in the program is this one, right? So from here we went back again here. So you can see, when you want to write a program, basically these are the steps. Whatever you are seeing on the screen, these are the most important things that you must remember all the time, because this is what you are going to translate into whatever it is asked. If it is asked to write assembly language program, then you will just convert these steps into assembly language instructions. If you are asked to write a C program, then you will convert these same steps into C program instructions, right? C program instructions are much simpler compared to the assembly instructions. Okay. So basically, what you must remember or you must practice is, first thing, you must remember all these steps one by one, and it's like you cannot even, some of them you can shift, like 2 and 3 you can interchange, that is okay, but almost all the time you should remember the sequence also. Step 1 2 3 up to 7, the sequence is also important to remember. Okay. In addition to these steps, what I have not written on this slide is to set whatever the pin is required to generate a pulse, to make that pin as output pin, because these steps what I have written are general steps for programming timer 0. I have not said what will be the purpose of the timer. Okay, here the purpose of the timer is not said. If the purpose of timer is to generate a pulse, then you will have to include the toggling bit toggle step here, or whatever the purpose of the timer is. Let's say you want to print 10 numbers after every delay, so you will print that number at that location. Whatever the task is given, that task has to go somewhere here between 3 and 4. Right now our task was pulse generation, so for that we toggled the bit. Okay, that we had done at this particular level. Okay, so this is how we write our program. If you have any questions, you can ask